Okay guys, I'm going to do a quick video on this unit here. This is my test unit. I've already been into it. It's already got a couple of values wrote down here for different voltages for your voltage mod, your overvolt protection. But this is another 1200 watt unit on 220, 900 watts on 110. HSTNS-PL11. This is our part number that we're most concerned with. Okay, so first thing you want to do is when you get your unit, because most likely it's going to be used. There is still some of these out there that are new. They're very expensive. Everybody's buying the used ones, which is fine. First thing you're going to want to do is power it up. So this first top pin here is 33, and the fourth one is 36. Okay, so you're going to want to jumper these two, 33 and 36, or pin 1 and pin 4 on the top, however you look at it. The second one in, which is a pin 34, that is your current share. So if you have multiple of these tied together, that's your current share to link them all together. So after you put your jumper in, come over here and plug it in. Make sure your fan comes on, you have your green light, and then check your 12 volt output. This is negative, this is positive. Positive's always on the outside of the case. Okay, so you've tested your unit, you know that it works. Go ahead and disconnect power. Let it sit there a second and drain, because if that fan's still spinning, then those caps are still charged and they will bite you. Okay, so a couple screws on this unit, 2 on this side. I've already taken the handle off, which it went here and here. I've already taken that off. 2 screws on the bottom. You have 4 across the top. 1, 2, 3. There's another one right here under the tape. 4. And then 1 right here. So, like I said, this is my test unit. I've already been into it. So it's only got 1 screw holding it in, so that I can pop it apart here. It says this one's at 15.9. So this folds over and it slides here. And of course this one's gonna, oh, there we go. And it slides back towards the fan and pops off. It's got those little locks there. Pretty simple. So first things first, let's zoom this in a little bit so we can see what's going on. Where my little ceramic screwdriver go. So this is the other thing too. I recommend using ceramic or plastic to adjust these. If you use metal and touch something that you're not supposed to touch, you're gonna end up, you know, in a bad situation. Okay, so this control here, this variable resistor, this is your voltage adjustment. Now, when you first crack these things open, this will go usually like 12 volts to 12.2 or 12.2 to 12.4. It doesn't give you a lot of variation. Okay, so I think I might be zoomed in enough. Let me bring it in a little more. All right, so this is our variable. You can see the pads are numbered 1, 2, and 3. Okay, so your resistor, which in this case is a 3.3K, goes from tab 1 of the variable down here, which is just a ground. So this is pin 2 of the ground, or pin 2 on the bottom here is ground. So if you wanted to make this power supply variable voltage, okay, you would set this, you know, if you had multiple of these, you'd set all of these the same 12.2 or whatever for an example. And then simply run a wire from here, and you can go to any DC ground. So you can run another wire from here. You can do it off of the tab, you know, the ground tab here, however, and make it variable voltage. But you can only go down so far, and you can only go up so far. We'll get into that here in a second. So let me slide that back over. So yeah, 3.3K is what I have here, and that will go up 16 volts, a little past 16. Don't want to go that high. Our DC filter caps here are only 16 volts, so you don't want to go, you know, past that. Probably not a good idea. Okay, so 3.3K will go up a little past 16 volts. 5.6K will go up to 14.6. I'm not sure how low it will go down because I didn't put it on my notes. I just put the top voltage. So 5.6K might go down to, you know, 13.8 and up to 14.6, somewhere around there if I had to guess. So get your resistor in for your desired voltage. And then comes the fun part. All right, so there's we got to pull this board out because our OVP circuit on this particular model has its own separate board. And you'll see the LED indicator right here actually works off of this overvolt protection board. Let me zoom that back out. Okay, so that actually works in conjunction. So 4 screws you got to take out. You got one here, one here, one in front of the fan. Let me get my light here so you can see that. There's one in front of the fan, and then buried right there on the edge of the power connector, there's another one. You can see it down there. So we got to pop these 4 screws out. So let me do that real quick. If I remember right, these are a number 1. Yep. So the screws that hold the board in are number 1. The screws that hold the cabinet together are number 2. So you need 2 different screwdrivers here. Get this one out. And finally, this one here. Okay. Usually you can flip it over and they'll fall out. Sometimes you gotta tap it and wiggle it around. This one's gonna be a pain in my butt. So we'll get the hemostats down here and grab it. Oh, I got stuck on the paper. That's why. It was loose. It just got stuck on the paper. All right, so got your 4 screws out. Set them over there. Don't lose them. The 2 on the DC side, or the secondary side of the power supply, are the longer screws. And the 2 back here on the primary or AC side are the short screws, just so you know. All right, so on this here, you're going to want to lift up the board. There's a little lip here on this edge of the cabinet, so we want to get the board past that lip, okay? So you'll lift it up a little bit and then slide it out. You don't have to go far, just enough to be able to get to this board, okay? And there's enough slack that you can move this around. You don't want to you know, pull on it real hard or anything, but there's enough slack there because I usually set them like this and then do my soldering. Okay, so we got our board out. Let me zoom in on this so that I can show you what we got going on. All right, so oh, dropped my little pointer. This is our little chip here. Okay, and it actually controls this transistor, and then this one talks to this one, talks to this one. They're all combined. Okay, so each one does a different, you know, one does, if the voltage is too low, under voltage, one does over voltage, one is current. The transistors all talk to the chip, and then the chip tells the supply, you know, raise your voltage, lower the voltage, shut down, it's too much, whatever. Okay, so this top transistor here, the bottom leg, okay, we're going to solder from here to this transistor here on the bottom leg, okay? So bottom leg on this one, bottom leg on this one. This is a 5.1K for the overvolt protection. And there is a little variance you can do on the other board there for that, but I usually don't mess with them. I leave them set wherever the control is set from the factory and leave it be. And then adjust it accordingly with different resistors here. So with a lower voltage, say you do the 5.6K for the voltage adjustment, it'll get you up to 14.6. You'll probably want a little more resistor here, 5.1, maybe 5.6, or you know, 6.1, 6.2K, something like that, right there. All right. So then we got to put our supply together. A little heads up: do not try to fire this thing up with no screws in it, because our AC goes to the chassis here right off the plug, and then the board grounds through this cabinet. So you want to keep that, keep the screws in it before you fire it up and put them back in. So we'll go ahead and do that real quick. Like I said, the two on the DC side here, these are your longer screws. So we'll get those dropped in. Sounds like the dog's finally up. Must be nice to sleep all morning. All right, I'm gonna let this dog out. All right. So when I put these screws in, I just put a couple turns on them and leave them loose. That way you can kind of move the board around if needed, to get it to anchor down. Like I said, I use hemostats to get down in here to drop the screws in the hole. It seems to work pretty good for me. Especially this one back here, it's under the power jack. It always wants to fight you. There's always got to be one, right? All right, get it dropped in. And this one here is the most important one, because like I said, this is the ground. This is how the board grounds through the chassis. So like I said, there's always got to be one that fights you. And unfortunately, I don't know how to edit videos, so you guys get to see me struggle with it. All right, once you get a couple turns on each screw, and you know the board's centered, then go ahead and tighten them down. All right. So now we got our overvolt done on this board here. We have our resistor in for our voltage adjust. It looks like my paper rolled under here. This little protective paper rolled under. Oops. Yeah. That's all right. Good enough for government work. There's nothing there to touch. Okay, so get our multimeter reader. All right. just a smidget so you can see that. Put my worn out alligator clips here to the meter. Ground. All tangled up because I'm such a professional. Alright, and hot. Alright. So, always recommend turning these variables down before you, on some of these, before you start it up. So, it's actually clockwise is down on these, if I remember correctly. I could be wrong. We'll find out here in a second. Alright. Power cord. Now, when these are apart, I always like to plug the power cord in and then plug, you know, this into the outlet. Just for the simple fact of the primary side is really stepping up that voltage. And, you know, you don't want to get zapped by anything in there. Alright, so we got our power plug in, plugged in the wall. Alright, so this has the 3.3K in it. Okay. And you can see with the variable all the way down, it started at 14.4. Which somebody might say, well, that's good enough. Well, if you didn't put the correct resistor on the overvolt, remember I told you the power LED works off of that, okay? So let me show you here. See, we got voltage on our meter, but we don't have a light yet. So as I increase this, there's our light, 14.5. I get that glare out of there. Okay, so that's the lowest this power supply can drop. Like I said, when you move the overvolt, you also move the undervolt. So with this resistor combination, 3.3 on the variable, 5.1 for the overvolt, the lowest this power supply can go and still function is 14.58. So if this power supply drops to, let's see, where's it going to go out at? Oh, it's already started, so now it won't. So if this supply drops below that 14.4, it's going to shut off. Okay, so you always want to have your overvolt set, you know, like in the middle of the range. So now we can take this all the way up. Right, with this resistor combo, it's going to top out at 15.9 all the way up. So I know at 15.9, I'm going to have to put a serious load on this thing and get it down to whatever it was, 14.4 or something, 14.5, before the undervolt kicks in and the overcurrent and shuts this supply down. So I have a little over a volt, volt and a half drop before this power supply shuts down. Okay, so zoom that back out. All right, so we're at 15.9. That's our max with this combo. These here are like 5% resistors, so it could be a little more, a little less, you know, with a 3.3K depending. I didn't measure it to get the exact. So this right here is your OVP, which you can adjust a little bit. Like I said, it's not going to give you much, so I just leave them right where they were from the factory. So you got that all done. You got your voltage set. Maybe you want, you know, 15.5 or something. You could adjust it here. Okay, there we go, 15.5 or whatever. Now, like I said, this supply with this combination, if you wanted lower voltage, 13.8 or something like that, like I said, you'd put a 5.6K here, and then the OVP would probably be like somewhere between 5.6 and probably 6.2 or 6.8, something like that, to change that. And then your power supply would work, you know, in that 13 point whatever up to 14 point whatever range. Like I said, you have two marks here. Okay, so to explain the current, you have, say you have, here, I'm going to make this simple, okay. This little pointer here, this is our voltage, alright. So that's our voltage we want. So when we put a resistor in there, and we'll say this side is upper, or overvolt, and this is undervolt. When you move the upper volt, or overvolt, the undervolt moves with it, okay. So when you put that resistor in there to adjust the voltage up, and then you have to do your overvolt, well, it also moves the undervolt with it, okay? That's the best way I can describe it. So you want to find something in the middle, or if you're going to really load these things down and work them really hard, then you would want your voltage to be closer to the overvolt, so that way you have more of a drop before the power supply goes into protection. Now this is a long video already. Alright, so let's take these clips off. We'll shut this down. Like I said, as long as that fan's still going, we still have some voltage in here. Okay, so don't touch anything, because it will bite you. Alright, so we got that far. Another long video. Like I said, these go on, slide up, fold over, put your screws back in, and it's done. Once again, this is the HSTNS-PL11. This is another 1200 watt version. This is an older one, so there's plenty of them out there. Everybody's gone and pillaged the PD30s. This is another option, the PL11. They also have a PD11, which I'm going to do a video on one of those here before long. But that's it, guys. So I hope that helps. You know, gives you a little, another option to look for with these power supplies. Like I said, they're drying up. The Bitcoin people and stuff like that picked them apart years and years ago, and now the radio community is picking them apart. So these power supplies here, they're pretty quiet, up to about 15.5 volts. We did testing on them with the HF radio from my radio guys. You go past 15.5, they start making noise about 14 megahertz and down. On up, no big deal, but yeah, that's it. Hopefully that helps, guys, and subscribe and turn your notifications on, because we're gonna keep doing these. I got a bunch of them that are hacked and ready to be shown. It's just getting time to do the videos. So like I said, I'm not a video editor. You're getting it however it goes. No editing here, so raw and uncut, I guess you'd call it. All right, guys, have a good one. Hope this helps.